Welcome. Today we are going to write a program in C++ that will convert a given decimal number into equivalent binary number. For this purpose, first of all, we are creating a new project in DevC++. As discussed before, click on File menu, select New option, select Project. Here we have to provide three options. First of all, select the console application, select project type or project extension, and here we will have to provide project name, and at last we have to save this project. So let's start. First of all, select console application, write its name. Let's suppose we are saying that TOB, decimal to binary. Click on OK and save this project. Default, we can see default program structure is already written because we are using DevC++. If we say here, this is the header file, this is the main function, and this is the return statement of main function. So let's start by creating decimal to binary using namespace std. This is already discussed in previous lectures. What is its meaning? First of all, we have to write here declaration statements. For decimal to binary conversion, we are using here one array of size 10. We will discuss it later on. This is used to store binary digits. As its size, we can notice that this array will save 10 binary digits. Okay, and secondly, we are going to declare a num variable of integer type that will use to store decimal input. We can write here used to store decimal input. Okay, and thirdly, we are introducing a counter variable that will use in iterations. Okay, let's start by taking input from the user. Enter decimal number, say num. Here we are taking input in decimal number. These are the declaration statements. Okay, we can zoom it. These are the three declaration statements, means which variables are required in entire program, and secondly, these are the two input statement. First one is message and second one is input statement. Okay, let's start further. Here we will provide logic for binary conversion. As we all know that binary numbers have base 2. Is it right? So we are going to write a loop starting counter variable from 0 to until num is greater than equal to 0 I plus plus. What's its mean we will discuss later on. Finding remainder by 2, that is base of binary number. First of all, we will get remainder of given number by 2, secondly, and then storing remainder in array. These are the steps that are required to compute equivalent binary number from the given decimal number. So let's start. We have AR array, its index is 0. We are getting modulus or remainder of num by 2. So let's start by discussing these two lines that are much more important in the decimal to binary conversion. Entire logic lies here. What is the purpose of this counter variable? This is starting from 0, means we are going to save first binary digit in 0 index, then it will increment it by 1, means next if binary digit exists will store in 1 index, 2 index, 3 index, and later on furthermore. And what is meant by this condition? It means number will be divided and we will get remainder out of the number until this number goes to tends to 0, not solved entirely. And this line means we are getting remainder, as we have discussed here. We are getting remainder of this number. Okay, zoom it. This is the iteration starting from 0 to num until num goes to 0, and this is getting remainder and storing it into array. Further, what is the step? If we do only these lines, then number will never reduce or tends to 0. For number to tends to 0, we have to divide it by required base. This is the important point. If we want to number tends to 0, then we have to divide it to the required base, means num is equal to num divided by 2. Okay, this is the entire logic that is required to convert a binary given decimal to binary. We are then displaying a message equivalent binary binary number. Equivalent binary number, we again have to print. We first of all reducing the counter variable I so that the null character will not be displayed, that is incremented by the counter variable. Okay, while I is greater than equal to 0, going to the first index, cout I minus minus. Okay, let's check its output. We can run and compile. As we can see here, program is asking for giving input. Okay, we are going to give input. Let's suppose we are giving it 10. Oh, very well, very well. We can see here the entire output clearly. Here we have given the input 10 and we know its equivalent is 1010, that is equivalent binary number. So we can run it again to check other decimal numbers. We give it 5, its equivalent is 101. The program is successfully run and the output is comparable and correct. So thanks for watching the entire video.